Given the graph of f prime of x, and we know that f of negative 3 equals 6, find the equation of the line tangent to f of x at x equals negative 3. All right, so the equation of a line tangent involves us finding the slope to get our, like the derivative to find our slope, and then also using a point. This is my point right here. That's my x sub 1, y sub 1. So if I'm thinking, all right, well, let's do y minus y sub 1 equals m times the quantity x minus x sub 1 and do point slope form, you're thinking the right thoughts. We have our point, and there it is. What we don't have is our slope. However, we have the graph of the derivative, and the graph of the derivative is going to give us our slope at that point. So if I care about when x is negative 3, I'm going to go over here to negative 3 and find out that when I have negative 3, I have a y value of negative 2. So my slope is negative 2. So I have a point of negative 3, 6, so your x sub 1, your y sub 1, and a slope of negative 2, and it's just a matter of me plugging things in. Y minus y sub 1, which is 6, equals m, which is negative 2 times the quantity x minus x sub 1, which is negative 3. So just cleaning this up a little bit, that double negative is going to become a positive, and I get x plus 3. So I'm going to do that guy right there. So kind of tricky because you're going to want to think, oh, I need instantaneous rate of change, or I need the slope. No, nope. This is the derivative, so you just want the value when I quote-unquote plug in negative 3. And I got negative 2. And that's what you do. That's what you get. Fun stuff. Find the derivative of y equals x to the x plus 1, provided that x is greater than 0. The purpose of this section is to kind of think outside the box a little bit. So this is me thinking outside the box a little bit. I don't like that. But I have a little rule about ln's that if I were to ln both sides like this, right? If you have inside of an ln, or a log for that matter, an exponent, you're allowed to bring the exponent out. Okay, that's something you learned back in pre-calculus, maybe even algebra 2. So what I have is I have ln of y equals x plus 1 ln of x. Okay? And so if I wanted to, I can kind of rip this apart and say ln of y equals, let's distribute x times ln of x plus ln of x. Now, I haven't even started yet. I have to find the derivative with respect to x of this. I have to find out what y prime is. So I'm going to use implicit differentiation. So I'm going to ddx both sides. Now, when you take the derivative with respect to x, okay, of a y, like I'm about to do here, you do the problem regularly, but at any point when you take the derivative of the y, you attach a dy dx. So the derivative of regular ln would be 1 over, so this is going to be chain rule, so 1 over y times the derivative of the inside means I'm going to multiply dy dx. Okay? Equals. This guy is power rule. So let me go off to the side, okay, and say that my u is going to be x, my v is going to be ln of x, which means my u prime is going to be 1, and my v prime is going to be 1 over x, and I want to write out u prime v plus v prime u. So this becomes u prime v, which is going to be 1 times ln of x, so just regular old ln of x, plus v prime u, which is going to be 1 over x times x, which is 1. Okay? I'm also going to differentiate ln of x with respect to x, which is just 1 over x. Okay? Now, my job is to get dy dx all by itself. So I have to multiply everything by y to get rid of this 1 over y. So it's just going to be regular old distributive property. Multiply everything by y. So finally, dy dx is going to equal y ln of x plus y over x. Okay, so not the prettiest thing in the world, Okay, not the belle of the ball, but you know, that's how you do it. That's how I did it. So enjoy. Now, upon further consideration, I'm not quite done with this problem yet. I guess maybe since y wasn't in the original problem, it may not be the worst idea for you to rewrite this like this. So dy dx, since y originally is x to the x plus 1, replace every y with x to the x plus 1. So this would be x to the x plus 1 ln of x plus x to the x plus 1 plus x to the x plus 1 over x. So I guess two different ways that you can write this out. I don't know. I like them both, but maybe this guy's a little bit better. Find the derivative of f of x equals 3 ln of x plus 4 ln of 2x. Now you might be looking at this and saying, oh, that's not that bad. I mean, that's regular and that's chain rule. But I think since this is this section, we're going to think outside the box a little bit. These are both ln's and I'm adding them. So why don't I just combine them into one single logarithm? So f of x, I could start out by moving that 3 up here and moving that 4 up here. So that would be ln of x to the third plus ln of 2x to the fourth, which, cleaning that up a little bit more, would be ln of x to the third plus ln of, what is that, 16x to the fourth. Now these guys, I haven't done anything, they haven't been added yet. When you add two logs or add two natural logs, you multiply the inside. So that's going to equal ln of 16x to the seventh, like that. Okay? So if that's f of x, then f prime of x is going to involve the chain rule. F prime of x is going to equal 1 over, keep the inside stuff, 16x to the seventh, but multiply everything by the derivative of the inside stuff. So 7 times 16 is 112 x to the sixth. Now simplifying this a little bit, 112 x to the sixth over 16 x to the seventh. I already know that that's going to be 7 because I just did it. And that's going to be over x because of the way that these simplify. Well, that was interesting. That was a lot of fun. Look at you. Find the derivative of f of x equals sine squared x times e to the 3x plus cos squared x times e to the 3x. If you're looking at this and thinking, ugh, product rule, but even worse because there's two sines, and product rule even worse because there's two cosines, and then chain rule and then chain rule, oh, you're thinking about it all wrong, child. All wrong. You see, I look at this and I see a sine squared and a cos squared. That's ringing a bell. Another bell that's being rung is the fact that I have e to the 3x in common in both. So why don't I bring out e to the 3x by factoring it out and see that I'm left with sine squared x plus cos squared x and realize, oh, that's a Pythagorean identity. Sine squared x plus cos squared x is just 1. So f of x is e to the 3x. So taking the derivative is just chain rule. The derivative of the outside stuff is just still e. Keep the inside stuff, but multiply everything by the derivative of the inside stuff. And then you end up with f prime of x equaling 3e to the 3x. Short and sweet. That's how you do it. Find the derivative of g of x if you have x to the third power over x squared plus 1 plus 2x over 2x plus 1. So what I can do is I can combine these guys and make that x to the third power plus 2x. That's supposed to be a plus sign. That's really not a good looking plus sign at all over x squared plus 1. Now that is plus 1, not minus 1. Don't expect any magic to happen. Okay, so now we have to use product rule. Okay, so I'll call you u and I'll call you v. All right, so u prime v minus v prime u all over v squared is going to be our guy. Okay, u prime is going to be 3x squared plus 2. V prime is going to be 2x. V squared is going to be 2x plus 1 quantity squared. So g prime of x is going to equal u prime v. So u prime was 3x squared plus 2 times v, which was x squared plus 1, minus v prime, which is 2x u, which is x cubed plus 2x, and that's going to be all over x squared plus 1. Now, I'm probably going to regret this. Probably going to regret it. And I could probably say, we're done. But I'm going to FOIL this out. just because I'm curious, I want to see what happens. Okay, FOIL that out. 3x squared, 3x to the fourth. Okay, 3x squared. 2x squared, 2. All right, minus 2x times x cubed, so minus 2x to the fourth. And not looking good right now. Minus 4x squared. Okay. And that's still over x squared plus 1 squared. All right. You guys combine to make x to the fourth. You guys combine to make 1x squared. And you guys are 2. Yeah, so it was a waste. Oh well. I had fun doing it though. Like, you can't factor that out. Nothing special happens. You can't hope for an x squared plus 1 because that will not happen. Not here, not with these numbers. And I'm just double checking because I'm paranoid, but I shouldn't be because I'm right. X squared plus 1 squared. So we gave it a shot. We gave it the old college try. Found out that, nah, it's just going to be regular product rule with gross stuff attached to it. So there you have it.